Hello, everybody. So moving on to lesson 3 for unit 7, we are going to be, well, in lesson 2, we added and subtracted. You could probably guess we are multiplying and dividing. So learning targets, I can multiply a polynomial by a monomial. Remember what a monomial is. That's a single term. So we're just multiplying by a single term. I can find the GCF of a polynomial and divide or factor it out of a polynomial. So learning target 1 is multiply, learning target 2, fancy word, factor, but that's meaning divide. All right, so multiplication is a little easier. So we'll start there. I'm gonna do some old things that we did in the last couple lessons to show you something that happens. So recall, simplify 5x to the third plus 2x to the third. So that was last lesson. It's combining like terms, that's 7x to the third, right? What operation is being used? Well, we were adding, right? Okay, or I could put addition, I guess. Does the exponent change with this operation? No, it did not change. It was 5x to the third plus 2x to the third became 7x to the third. All right, next one. This actually goes back to the last unit. 5a to the third times 2a to the second. That would be 10a to the fifth. What operation is being used? Well, that was multiplication. Abbreviate that. Does the exponent change with this operation? Yes, it does. When we multiply, the exponent did change. That's what I wanted you to see. Does the operate? What changes the exponent? Okay. So the summary of what I just talked about is when adding or subtracting, so addition and subtraction are kind of the same. When adding or subtracting terms, the exponent does not change. But in multiplication or division, the exponent does change. Okay. So keep that in mind as we go through this. All right. And it's really going to come into play when we move on to the next lesson, but that is a big one. What I just talked about there is big. Okay. I'm going to scroll down now. And we're going to try it. So multiply each monomial into the polynomial. So basically it's distributing. It's essentially what we're doing. So 3 times x squared is 3x squared. 3 times 4x is 12x. And 3 times -5 is -15. You might be wondering, well, no exponent change there. Well, it's because I didn't multiply 2 exponents together. I multiplied 3 into each of them. There was no exponent being added in or multiplied in. In number 2, there is. 4b is getting multiplied in. So I'm adding, basically I'm putting 1b in there. So what I'm doing is 4b times 5b squared. So you're basically doing 3 problems that we did in the last unit, all in one problem. So 4b times 5b squared is 20b to the third. And then 4b times -b. So 4 times -1 is -4. B times b is b squared. And then 4b times 1 is just 4b. Right. Number 3, 7h to the third. 7 times 3 is 21. I have 3 h's that I'm putting with 4 h's. That's 7 h's. 7 times 2 is 14. And then I have 3 h's putting with 1 h that's already there. I now have 4 h's. Essentially what you're doing is just, I'm kind of using a verb here, verbiage that I want you to kind of think of it. I'm adding 3 h's in to each of those terms that is inside the polynomial. Okay, so adding 3 h's in, I went from 4 h's to 7 h's. I had 1 h, now I have 4 h's. Okay, last one has 2 variables in it. It's still a monomial. 2ab to the third is still a monomial. There's no plus or minus in 2ab to the third. But it does change how you do it a little bit. You just have to combine like term or like bases. So 2 times 4 is 8. I'm putting 1a in. There's 2 there, so now there's 3 a's. There's 3 b's getting put in. There was already 1 b there, so there's 4 b's. That's your first term. Second one, moving on to the second one. 2 times -5 is -10. 1a getting put in with no a's, so it's still just 1a. 3 b's with 4 b's, there's 7 b's. These are not like terms. To be like terms, they would have to have the exact same exponent on both bases. So I'm done. I can't put those together. Okay, that's it. Before I move on to the next part, I want to show you some things that happen. The original polynomial. So I'm going to use a different color here. The polynomial that's inside the parentheses. I'm going to show you some common things that happen here. There were 3 terms in the first one, right? Look how many terms are in the answer. 1, 2, 3. 3 terms in the original polynomial in number 2, 3 terms in your answer. 2 terms in number 3 inside the original, 2 terms in the answer. See that? Hopefully you see that pattern. Okay. So now there are a couple other patterns, but I'm going to get to the end first before I talk about that. So moving on, I'll just stay with red. Okay. From 4th grade, so yes, we're going way back, list all factors of 36. So I'm going to go factor pairs. So 1 and 36, I'm going to kind of space them out like this. 1 times 36 is 36. 2 goes into 36 18 times. 3 goes into 36 12 times. 4 goes into 36 9 times. 5 does not go into 36, and 6 does 6 times. And there's your factors. Okay. That question was just making sure you know what factors are. Now, find the GCF, or greatest common factor, of 12 and 18. You might know it. A lot of you probably do. Just looking at it, you could say it's 6, and you're right, it is 6. But what I'm going to do is I'm going to show you, if you don't know it off the top of your head, here's what you can do. 12, I'm going to go 1 and 12, 2 and 6, 3 and 4, and that's it. 18 is 1 and 18, 2 and 9, 3 and 6, and that's it. Now you're just looking for the number that's the biggest in common. So they have 6 in common. That's the biggest. So the GCF is 6. They also have 3 in common, and 2 and 1, but you want the biggest. So it's 6. All right. What does that have to do with anything? Why did I go back to 4th grade there? Well, scroll down or go to the back page and we'll see. Apply it to algebra. Let's find the GCF now of 4x to the 3rd, 12x squared, and 8x. You're like, oh crap, now we're throwing letters in. Really doesn't make it that much harder. Let's go with just 4. So 1, 2, and 4 are the factors of 4. And then there's 3 x's. I'm just going to write 3 x's out. 1, 2, 3. Now I'm going to do 12x to the 2nd. Okay. 1, 2, 3, 4, 6, and 12, and then 2 x's, right? Not 3 this time. Last one is just 8x. What do these have in common? 1, 2, 4, 8, and then 1x. I am going to circle the GCF of the numbers first. Hopefully you see that it's 4. They all have a 4, and it's the biggest. And I'm also going to circle the GCF of the x's. How many x's are in each of them? Well, there's only 1 in the last one. And they all have an x, so I'm going to circle that too. So the circled terms, or the circled numbers, become your GCF. So the GCF is 4x. Okay. Now, all this work here, you're not going to have to do that over and over again. You can if you get stuck, but you don't have to. A lot of people can look at this once you've done a few practice problems, and you can say, just look at it and say, oh, yep, it's 4x. Okay. It won't take you that long, but we're at the very beginning of this. If you're not doing that yet, it's okay. All right. So let's go down. This is what you're going to see. Find the GCF of each polynomial. So in the first problem up here, I just put commas in between them. Now I'm putting pluses and minuses in polynomial form. Okay. So we want to look at, find the GCF of the numbers and then also the letters. So the numbers, pretty easy. 4, 10, and 14. Give you a second to think about that. Hopefully you realize that it is 2. Okay. Now the x's. X to the 3rd is the most number of x's I could take out. Before I move on, I do want to do this one problem one more time the old school way. 4x to the 5th. So 1, 2, 4, and then 5 x's. $12x to the 2nd, or sorry, no, 10x to the 2nd. I'm looking at the old problem. 10x to the 4th is what I'm doing here. So that's 1, 2, 5, and 10 with 4 x's. And 14. Notice I don't really even care about the negative. That'll just get taken into account later. We'll deal with that later. 1, 2, 7, and 14 with 3 x's. Okay, they all have a 2. That's the biggest number they have in common. And then this is what I wanted to show you. They have 1, 2, 3 x's in common. So that's why the GCF is 2 and then xxx, which is x to the third. That's where the GCF comes from. Number 2 here, 3t to the squared, 3t squared minus 18. The GCF of the numbers is 3. The GCF of the letters is actually, there is no GCF. I can't take a t out of 18. 18 has no t's, so I can't put a t in the GCF. The GCF in this one is just a number, 3. Number 3, trick one here. The numbers have no GCF. Well, it's 1, right? You can always have 1. But 4, 6, and 3, the only one they have in common is 1. And then there's no x's in 3, so I can't take any x's out. The GCF on number 3 is 1. We would say this has no GCF, is what we would say here, if it's just 1. Okay? All right. Almost done. Finding the GCF is only the first step in factoring. This is what I'm going to call it a lot. So you have to understand what I'm talking about when I say factoring. This is only the first step in factoring a polynomial by a monomial. Okay, so the first step is finding the GCF. The second step, which we haven't done yet, is dividing each term by that GCF. Okay, so bottom of the page here, 6 questions. Factor out a monomial from each polynomial. So first thing is find the GCF. I like to write it out. Okay. Now, the GCF on number 1, again, we practiced this, so I'm gonna go a little quicker now, is 3x. All right. Now, the second step is the new part. We're dividing each thing by 3x. 6x to the third divided by 3x. 6 divided by 3 is 2. If I have 3 x's on top and 1 on the bottom, that leaves me 2 x's on top. By the way, if you get a fraction here at the end, you didn't do it right. There shouldn't be any fractions. You shouldn't have any negative exponents either, if you do it right. Negative 12x squared divided by 3x. Negative 12 divided by 3 is negative 4. 2 x's on top, 1 on the bottom. There's only 1 left, so just x. 9x divided by 3x, well, 9 divided by 3 is 3. X divided by x, those cancel. There's no x's left. Now, a lot of people do that. They think that that's it. You're not done. This is actually not right. What you're doing when you're factoring is you're just changing how the problem looks. You're not changing its value. So what I mean by that is, at the end, what goes on the line should be the same as the original problem. It just looks a little different. Okay. So what do I mean by that? Well, I'm gonna go over here and show you something. Let's say I have 40 plus 24. Okay, we know that that's 64, right? I'm gonna change how I write that. I'm gonna take out the GCF of 40 and 24, and that's 8. I'm gonna take 8 out. 40 divided by 8 is 5. 24 divided by 8 is 3. If I just do 5 plus 3, I'm not going to get the same answer as what I had at the beginning. 5 plus 3 is 8, right? We said 40 plus 24 was 64. Factoring should not change the value, but in that case, I did. What I need to do is take the 8 that I divided out and put it in front. Okay? If I do that, 8 times 8 is 64, and I'm back to what I had started with. That might have been confusing. If that was confusing, ignore that. We'll move on. But what I need you to do is you need to take the GCF and you have to write it out in front. Okay? Now, you'll probably notice this looks like what we did at the very beginning of the notes, and it is. This is a monomial. 3x is a monomial. If I distributed that in or multiplied that in, guess where I would get? I would get right back to my original problem. So factoring and multiplying kind of undo each other. All right? That's essentially what I want you to see. Okay. Factoring you will use way more than multiplying, but we will be using some multiplication in this unit. I'm gonna go ahead and delete everything and start with number 2. What is my GCF? It is 4x to the second. Now here's a little tip that I'm going to tell you, and it's going to save you lots of points if you listen to it. It's very easy to forget to write the GCF in front, but we've just found the GCF. To not forget it, I'm going to write it right here from the beginning. Boom. Not going to forget it now because it's on the line. I'm going to divide both things by 4x squared, and whatever I get when I divide is what's going to go inside the parentheses. All right. So 8x to the 5th divided by 4x squared. 8 divided by 4 is 2. 5 x's, take 2 out, you're left with 3 x's. Negative 12 divided by 4 is negative 3. 2 x's, take 2 out, there's none left. So there's your final answer. Okay, we go a little quicker with 3, 4, 5, and 6. The GCF on number 3 is 5. Can't take any d's out. I'm going to put that 5 right there. Divide both by 5. 5d to the 3rd divided by 5. The 5's cancel. I'm left with just d to the 3rd. 20 divided by 5 is 4. Boom. Done. Number 4, we haven't seen one like this. The GCF has no numbers that I can take out other than 1, but I can take 2 x's out. So the GCF here is just a letter. It's x squared, and that is okay. That can happen. So now I'm just going to take and divide each thing by x squared. So 2x to the 4th divided by x squared. Well, there's still 2 divided by 1 is just 2. 4 x's, take 2 out. I'm left with 2. 5x to the 3rd, take out 2 x's. It's just going to be 5x. 6x to the second, negative 6x to the second divided by x squared is just negative 6. No x's left. Okay, number 5. Thinking about almost skipping this one, but I'm going to go ahead and do it. There's no GCF here. It's a 1. So the answer is nothing changes. You're going to divide by 1 and not change it. Okay, that one's done. And then the last one here, the GCF on this one is 6p to the 3rd. Okay, we'll go ahead and write that on the line. Divide everything by that GCF. Six divided by 6 is 1. 5 p's, take out 3 p's, you're left with 2 p's. 12 divided by 6 is 2. P to the 4th divided by p to the 3rd. Had 4, take 3 out, left with 1. Negative 18 divided by 6 is negative 3. No p's left over. Okay, before I'm done, I want to show you a few things that happened. Make sure you see these. These are very, very helpful if you see them. The patterns are huge. You know you've gotten the right GCF if at the end, notice how each of these has no variable left. The last term has no variable left. You know you have the right GCF if that's the case. Another thing you can tell, look at the last term in the original polynomial. Okay, if you look at the last term in the original polynomial, the letter should match the GCF and the exponent. As long as it's in standard form, make sure you hear me on that. It's got to be in standard form. Look at the last term. X squared, boom, x squared. Original one was, again, x squared. GCF had x squared. Last term had no x, same with the GCF. Last term had 3 p's, 3 p's. Last term had no variable, no variable. These are all common things that are going to happen if you do it correctly. Okay, and these are little things that if you notice them, you know you're going to gain confidence in what you're doing. Okay, that's factoring a monomial. We're going to do factoring more in lessons 5, 6, and 7. But for now, that's all we're doing. And that is the end of this video.